Example 2.58. Exercise number 2.8. Example 2.58. Evaluate integral 0 to 1 e power x minus 4 into a power x plus 2 plus cube root of x into dx. Here there are three functions on constant value. The total function have the functions as different combined differently by addition subtraction. So this is a combination of functions, so we can directly integrate. We need not give any substitution that and all. For e power x we have direct formula, a power x we have direct formula. For integral 2 is a constant, directly we can integrate. Here cube root of x that is x power 1 by 3, we can directly integrate by x power n. So I am applying directly integration here. Integrating e power x, so integral e power x minus 4 into integral of a power x is a power x divided by log a, and then for every constant, if integral dx is x is multiplied, so 2x. Cube root of x means x power 1 by 3, so by x power n plus 1 formula, x power n plus 1 by n plus 1, x power 1 by 3 plus 1 divided by 1 by 3 plus 1. The lower limit and upper limit are applied here. After integrating, no integral symbol here, instead 0 and 1 are at the end of here are substituted. And then now substitute the upper limit, then the lower limit. Substituting upper limit, instead x e power 1 minus 4 a power 1 by log a plus 2 into 1 2 plus 1 power 1 by 3 plus 1, 1 power anything is 1 divided by 1 by 3 plus 1, taking LCM 1 plus 3 by 3, that is 4 by 3. Then minus of lower limit is 0, substituting 0 for all the places of x again. Now e power 0 minus 4 a power 0 by log a, then here plus 2 into 0 0, then 0 power anything is 0. Now simplifying this, we'll have e power 1 is e minus 4a by log a plus 2 plus 1 by 4 by 3 as 3 by 4, then minus, bring this minus inside, e power 0 is 1, so minus 1, this minus into minus plus 4 a power 0 also 1, so 1 by log a, then remaining are 0. We can simplify this more. 2 minus 1 is 1, 1 plus 3 by 4, totally these values 2 plus 3 by 4 minus 1 equal to 2 minus 1 1, then remaining 3 by 4, 1 plus 3 by 4, taking LCM 4 plus 3 by 4 equal to 7 by 4. So these three terms become 7 by 4, and remaining of the second term and last term, we can take out 4 by log a as common, which implies which is equal to e, then the constant values are simplified as 7 by 4 plus 7 by 4, and then taken 4 by log a common from these two terms, plus 4 by log a is taken out from the two terms, the remaining are minus a, here totally is taken out 1, so 1 minus a is the final answer of example 2.58. When we multiply here, 4 by log a, this term will appear, then minus 4a by log a, this term will appear. So the total answer is e plus 7 by 4 plus 4 into 1 minus log a by log a, or 1 minus a by log a, or 4 by log a into 1 minus a. That's all. Once again I am explaining here. The 0 to 1 e power x minus 4 a power x plus 2 plus cube root of x dx is given. The integral of e power x is e power x minus 4 constant, then the function a power x is integrated by the formula a power x by log a. Every constant dx means x will be multiplied, dt means t is multiplied, because 2 into integral dx become x, so it is 2x. This is a cube root of x, that is x power 1 by 3. By using x power n formula, x power n plus 1 by n plus 1. Here, substituting the upper limit e power 1 minus 4a power 1, here there is no x. Substituting 1 for x, all the terms in x, we should substitute a value of upper limit 1. Here 2 into 1 2, then here substituting 1 power anything is 1, then 1 by 3 plus 1 is 4 by 3. Here substituting the lower limit minus the lower limit value, e power 0 minus 4 into a power 0, e power 0 minus 4 into a power 0, 2 into 0 0, 0 power anything 0 by 1 is 0. So remaining are e minus 4a by log a plus 2 plus 3 by 4. Now multiply this minus inside, e power 0 is 1, so minus 1. Then here plus 4 into a power 0, 1 by log a. So 4 into 1 by log a, 4 by log a, or 4 into 1 by log a. These two are be 0, we can leave it. So remaining are, these are the terms remaining. So e is taken here. Then simplifying these three values, we will get 7 by 4 is applied here. The remaining are minus 4a by log a plus 4 by log a. From these two, 4 by log a is common out, taken out. 4 by log a taken out, here is 1 remains. And then here 4 by log a taken out, remaining is minus a, that is 1 minus a. This will be the final answer. Example 2.59 now. Given integral pi by 6 to pi by 3 sin x dx. Pi by 6 to pi by 3 sin x dx. We should find the value, that is area between pi by 6 to pi by 3. Example 2.59. Integral pi by 6 to pi by 3 sin x dx. Pi by 3 is 30 degree, pi by 6 is 30 degree, pi by 3 is 60 degree. We should find the area of sin x between 30 to 60 degree with the x-axis. That is the problem. The area will be equal to some answer. We will find out now. Here, you can directly go by a formula of integral sin x. Integral sin x dx is equal to minus cos x plus c. So substituting instead sin x here, which is equal to cos x limit pi by 6 to pi by 3 minus cos x limit pi by 6 to pi by 3. Now taken out minus, and then substituting upper limit cos pi by 3 minus lower limit cos pi by 6. We are familiar the trigonometry table values. Cos 60 is 1 by 2, then minus cos 30 is root 3 by 2. So now the 1 by 2 is taken out, minus 1 by 2 into 1 minus root 3. Now multiplying this minus inside, will have 1 by 2 into root 3 minus 1. 1 by 2 minus inside, we have root 3 minus 1 inside, then 1 by 2 here. Therefore, the area, the value pi by 6 to pi by 3 sin x dx will be equal to 1 by 2 into root 3 minus 1. This is very simple. Just substituting, integrating sin x as minus cos x, then upper limit minus lower limit. Easily we can get the result. We should know the value of cos 60 degree is 1 by 2 and cos 30 degree is root 3 by 2. This is very important thing. So all the basics you should know, and in addition you should know thorough the integral formulas and the trigonometric formulas, whatever you have learned in 11th standard. You should keep all those things in your mind. Then only you can easily complete the integration problems. Example 2.60 now. Integral 0 to pi by 2 cos square x dx. Here I have introduced a formula in the previous exercises. Now the equivalent trigonometry formula for cos square x without square. You should choose formula without square. You should choose. That is cos square x is equal to 1 plus cos 2x by 2. Now substituting here the equal value 0 to pi by 2. Cos square x is replaced by the formula 1 plus cos 2x by 2 into dx. Because we don't have formula to directly integrate a cos square x. If it is cos x, we can directly integrate, but cos square x, we don't have formula. But for cos square x, we have one more trigonometry formula, 1 minus sin square x. Often it will be in our mind, but we couldn't choose that formula because if we go with that, we don't have directly integrate sin square x. So you need not choose such a formula. So choose a formula which is without square for cos square x. So I have chosen 1 plus cos 2x by 2 formula. That is very important. The chosen formula, the terms involving the chosen formula should have a integral values. That only chosen. Here 0 to pi by 2, 1 plus cos 2x by 2 into dx. Here 1 by 2 taken out. The remaining are 0 to pi by 2, 1 plus cos 2x into dx. Now we can integrate this because there are two functions. One is one constant, another one is cos 2x. Both are combined by addition. This is very easy to calculate. So integrating every constant, if dx means x multiplied, that is integral dx is x. Now 1 by 2 into x plus, now integral of cos ax, just now we have learned formula, integral of sin x is minus cos x. For integral of cos x is sin x, but integral of cos ax dx is equal to sin ax by a plus c. Now here plus sin 2x, a is 2 by 2, limit 0 to pi by 2. Now substituting the lower and upper limits, we will have, which is equal to 1 by 2 into, first substitute pi by 2 for x, pi by 2 plus sin 2 into pi by 2 divided by 2. Then minus of the lower limit, substituting 0, 0 plus sin 2 into 0, sin 0. So the sin 0 value is totally 0. So totally they become, two terms become 0 when substituting the lower limit. Here x becomes 0, here substituting x is equal to 0, sin 0 is value 0. So totally the lower limit value fully 0. So we can simplify the upper limit values here. We need not cancel these two, but we can cancel these two values. Now 1 by 2 pi by 2 plus sin pi whole divided by 2, not sin pi by 2, sin pi whole divided by 2. And then these are 0, we can leave it. 1 by 2 into pi by 2, then sin pi again 0. So 0 by 2 is 0, we have pi by 2. Now multiplying this, we will have pi by 4. So the value of integral 0 to pi by 2 cos square x dx is equal to pi by 4, which is equal to pi by 4. Example 2.61 here. Integral 0 to 1 e to the power a log x plus e to the power x log a. E to the power a log b is equal to e to the power log b power a, that is equal to b power a. We have learned one formula in the logarithmic integration. By use of this, we can convert this one as x to the power a, and then the second one as a to the power x. So it is equal to integral 0 to 1. The value of this one is x power a plus the second one's value is a power x into dx. Now this is x power n formula, this is a power x formula. Here a is a constant. So by integrating, x power a plus 1 divided by a plus 1 plus a power x means a power x divided by log a is chosen. 0 to 1. This is very simple. Substituting these equivalent values and then we can integrate, because the two different functions, they are different functions combined by addition. So individual functions directly we can integrate. We have direct formula to integrate this x power a and a power x. For x power a means it is x power n formula, x power n plus 1 by n plus 1. For a power x it is a power x by log a formula. Very simple. Now we can substitute. Now substituting the upper and lower limit here for x. Substituting 1 here, 1 power a plus 1 divided by a plus 1 plus a power 1 by log a. This is the substitution of the upper limit for x. Upper limit is 1, substituting x, 1 power a plus 1 by a plus 1, a power 1 by log a, minus the lower limit. Lower limit is 0, substituting here 0 by a plus 1 is 0, 0 power anything 0, 0 by a plus 1 is 0, plus a power 0 by log a. Now, this is 1 by a plus 1, 1 by a plus 1, because 1 power anything is 1, plus, but 1 power infinity is indeterminate. Here 1 power a constant value, finite value is 1, plus a by log a, and then minus, plus into minus minus, a power 0 is 1 by log a. Now we can take 1 by log a common from these two, which will be equal to 1 by a plus 1, then taken out 1 by log a plus 1 by log a into a minus 1. It will be the answer for 2.61 here, 1 by a plus 1 plus a minus 1 by log a or 1 by log a into a minus 1. 2.62 example, under 2 to 3 x power 4 plus 1 by x square into dx. We don't have direct formula, just split the denominator to both the terms in the numerator. That is equal to integral 2 to 3 x power 4 by x square plus 1 by x square into dx. Here x square and x power 4 cancel, remaining is 2 to 3 x square, dividing x power 4 by x square will get x square, then 1 by x square, 1 by x square dx. We can go with directly integrate because these are the two different functions. We have direct formula to integrate these two functions. The first one is integrating x power n formula, x power n plus 1 by n plus 1. So 3 by 3 plus here 1 by x square we have. For 1 by x square, 1 by x power n formula, integral 1 by x power n dx is equal to minus 1 by n minus 1 x to the power n minus 1 plus constant of integration c. So substituting here, minus 1 by 2 minus 1 is 1 into x to the power 1, and the limits are 2 to 3. When simplified, it will be equal to minus 1 by x. Here we have x cube by 3, and then multiplying these two, minus 1 by x, limit 2 to 3. Now substituting the limit values. First substitute upper limit. For upper limit, substitute x is equal to 3. 3 power 3 by 3 minus 1 by 3. Minus of the lower limit, 2 power 3 by 3 minus 1 by 2. Here we can cancel these two. That is 3 power 3, 27 by 3 is 9. Minus 1 by 3. Now bring this minus inside. Minus 2 power 3 is 8, 8 by 3, minus into minus plus 1 by 2. Here these two implies minus 9 by 3 equal to minus 3, equal to 9 minus, these two have equal denominator, we can add the numerator 9 by 3 plus 1 by 2. So 9 by 3 is 3, so 9 minus 3 is 6 here, 6 plus 1 by 2 we have. 9 minus 3, 3. Then plus 1 by 2. 6 plus 1 by 2. Which will be equal to, taking LCM, 12 plus 1 by 2. That is 12 plus 1 by 2 equal to 13 by 2. That is equal to 13 by 2. 9 minus 9 by 3. This is 9 by 3 is 3. So 9 minus 3 equal to 6 plus 1 by 2. So taking LCM, 12 plus 1 by 2, that is equal to 13 by 2 is the final answer. Example 2.63, integral minus 1 to plus 1, x cube plus 3x square whole cube into x square plus 2x dx. Now look at the function into the power, within the power, that is x cube plus 3x square. X cube plus 3x square. Differentiate it. 3x square plus 6x is its derivative. Now take out 3 as common. X square plus 2x remains. The term within the product is x square plus 2x. That is the derivative of the function within the power. So you can give substitution for this x cube plus 3x square as f of x. Then the remaining term become f dash of x by 3, because we have only x square plus 2x here. So dividing by 3, it will be equal to f dash of, if it is f dash of x, taken as f of x, and this one is f dash of x. So f dash of x by 3 will equal to x square plus 2x. For x square plus 2x, we can substitute f dash of x by 3. So we can go with this substitution. We can easily complete. Else we should expand it by by 3 power 3, then multiply with the term x square plus 2x. Then you can integrate. That will be more difficult comparatively this step. This is a method. So I am choosing the same way of substitution here. Put f of x is equal to x cube plus 3x square. Then f dash of x is equal to 3x square plus 6x. So dividing by 3, f dash of x divided by 3 equal to x square plus 2x. So 1 implies integral minus 1 to plus 1, no change of interval limits, because we are keeping the function as x only here. So you need not to change the limits. You can directly substitute. This one is f of x whole cube, and the remaining are f dash of x by 3 into dx. Taking 1 by 3 out, 1 by 3 integral minus 1 to plus 1 f of x whole power 3 into f dash of x dx. We have formula here, integral f of x whole power n into f dash of x dx will be equal to f of x whole power n plus 1 by n plus 1 plus c. So by substituting here, this is equal to 1 by 3. F of x is x cube plus 3x square. So x cube plus 3x square whole power n plus 1, 3 plus 1, 4 divided by 4, and then the limit is minus 1 to plus 1. By taking this 4 out, 1 by 3 into 1 by 4, it is 1 by 12. Now x cube plus 3x square whole power 4, limit minus 1 to plus 1 we have. So applying upper limit and lower limit now, 1 by 12 into, substituting 1 now, 1 cube 1 plus 3 into 1 square 1, so 1 plus 3, 4 power 4, minus of the lower limit, substituting minus 1, minus 1 cube minus 1, and then minus 1 square plus 1, 1 into 3, 3 plus 3 power 4, which is equal to 1 by 12 into 4 power 4 minus 2 power 4, which is equal to 1 by 12 into, this can be written as 2 power 2 whole power 4, 2 power 8 minus 2 power 4. So remove 2 power 4 as common, 2 power 4 by 12 into, here 2 power 4 minus 1. So 2 power 4 by 12, 2 power 4 means 16 divided by 12 into 2 power 4, 16 minus 1. Can cancel by 2, 8 by cancel by 4, that is 4 by 2, 4 by 3 here, 4 by 3 into 15, that is equal to 4 by 3 into 15, that will be equal to 60 by 3.